Welcome to The Explainer. Today, we're going to pull back the curtain on the secret life of light. We're talking about the science that lets everyday gadgets actually see light and turn it into action.
You know that moment, right? You walk up to a store and the doors just swoosh open for you. It feels like magic. But how does it actually know you're standing there?
Or what about at the checkout? The cashier zaps a barcode with that red light and boom, the price pops up on the screen just like that. How in the world does it get all that info from a quick flash of light?
And then you've got solar panels. I mean, think about it. We stick these things on a roof, sunlight hits them, and suddenly we have electricity. It's like creating power out of thin air. How is that even possible?
Okay, so you've got the automatic door, the scanner, the solar panel. They all feel a little bit like everyday magic. But here's the thing, it's not magic at all. They all share one single, really elegant secret.
And that secret, the thing at the heart of all this tech, is a little device called a photoelectric transducer. Yeah, I know, it's a bit of a mouthful, but its job is actually super simple and incredibly powerful. All it does is take in light and spit out an electrical signal.
So that's the big question, right? How does that conversion from light to electricity actually work? Well, to get the answer, we have to go back in time, to a little something from one of the most famous minds in history.
It all comes down to something called the photoelectric effect. And yeah, this is the very thing that Albert Einstein famously explained. It's actually what he won his Nobel Prize for, not relativity. The idea is pretty simple. When light hits a certain type of material, it can literally knock electrons loose, or kind of give them a jolt of energy. And that movement of electrons, well, that's what electricity is.
Let's break it down. It's really just a quick four-step dance. Step 1, a tiny particle of light, a photon, shows up. Step 2, it smacks into a special, sensitive material. Step 3, it transfers all its energy to an electron. And Step 4, that newly energized electron gets moving. That movement is the electrical signal, a current or voltage that a machine can actually read.
And here's the really cool part. It's a totally direct relationship. The more light you have, the stronger the signal you get. It's that simple. Brighter light means more photons hitting the surface, which means a stronger electrical signal. And because it's so predictable, that's what makes these little devices so incredibly useful.
All right, so engineers, being clever folks, took this one core idea and basically created 3 different versions of it. You can think of it like a toolkit, right? You've got different tools for different jobs. And it's the same idea here.
So let's look at the 3 main types. First up, you have photoemissive. This one is super sensitive. Light hits a metal surface and literally boots electrons right out of it. This is perfect for scientific instruments that need to pick up on really faint light. Then you've got photoconductive. This one's a lot simpler. Light just changes how easily electricity can flow through a material. It changes its resistance. These are simple, cheap, and reliable, which is why they're perfect for things like those automatic doors we talked about. And finally, there's photovoltaic. Now this is the one you already know. It's our solar panel. It's the rock star of the group because it generates its own power directly from sunlight. No external battery needed.
Okay, so you've got these 3 different tools in the box. If you're an engineer, how do you pick the right one for the job? Well, like with pretty much any technology, it's all about trade-offs. There are some huge pluses, but also a few things you've got to watch out for.
Let's start with the good stuff, the upside. And the advantages are huge. First off, they are incredibly sensitive and react almost instantly. We're talking lightning fast. They can also work without physically touching anything, which is a game changer for things like factory assembly lines. Plus, for the most part, they're super reliable, tiny, and lightweight. But you know, it's not all perfect. There are some hurdles. For instance, their performance can get totally messed up by something as simple as a bit of dust, or even just stray light from a lamp in the room. Temperature can throw them off too. And some of the really powerful ones can be kind of bulky or need a serious power supply. And sometimes, the signal they create is so tiny, you need to boost it with an amplifier just to make it useful. So when you put all that together, the good and the bad, where does this technology actually show up in our lives? Well, it turns out it's pretty much everywhere, powering our world in ways you probably never even realized.
No, really. The impact is massive. In factories, they're the invisible eyes watching over everything, detecting parts on a conveyor belt, or creating a safety curtain of light that instantly stops a machine if someone gets too close. They're used in tools that measure light levels, and even in flame detectors that are smart enough to spot the specific flicker of a fire. And of course, they bring us right back to where we started, the automatic doors, the barcode scanners, and all those solar panels out there soaking up the sun.
Yeah, this really hits the nail on the head.
They're not always the star of the show, but they are absolutely essential. They're the invisible, unsung heroes that make so much of our modern tech possible. Think of them as the quiet, efficient translators, constantly converting the language of light into the language of electricity.
Isn't that incredible? You have this really deep, complex idea from physics, something Einstein figured out, and now it's the invisible engine running behind the scenes in countless things we use every single day. It's just a perfect example of how that kind of big idea science can lead to tools that literally change the world. So the big takeaway here is that light is way more than just something we see with our eyes. It's an active force. It's a tool that we can use to sense, to measure, and to power our world. And now that you're in on the secret, the real question is, where else are you going to start noticing it at work?